Hi, I'm Trevor Magnuson. I'm learning to make guitars and I'm sharing the process that I use. It's come time to make the sides, so I have a nice piece of Tasmanian blackwood and some cheap pine, ripped and cut to size. So let's get it resawn and milled to thickness. We now have the sides milled down to 2mm in thickness and the bindings 1.7. That's very thin. Obviously we're going to laminate. So the question you might be asking is why? The first answer is that where I live I get a lot more choice of nice Tasmanian blackwood that is kiln dried than air dried. And kiln dried timber is harder to bend, so cutting it really thin makes the job easy, or indeed possible. The second answer is that laminated sides are far stronger than solid timber. Once we laminate, the shape that it's in is the shape it's going to stay in. We barely need the Solera mold to hold the shape. You might also be asking why this cheap wood for the inside layer. And the reason for that is, firstly, this is a guitar that I'm learning to make. This is not a guitar for sale. And secondly, sides are structural. They're not really tonal. So why not? Let's get bending. First of all, let's meet the players. We've got a Fox style steam bender, 3 heat lamps in the bottom. We've got our mold with this insert for the top side and the cutaway side. And then we've got some flashing and some shim stock to even out the heat and the pressures when bending the wood. On the bottom I've got some aluminium flashing spray painted with black enamel to absorb heat from the heat lamps, and then we've got this steel shim stock. Just as when we were making the access port, we're using aluminium foil to protect the wood from metal dust and to keep the steam in. There is another trick that I'm going to be doing, and that is we are going to have the 2 layers the wrong way around. That allows the wood that is going to be the show face to be protected on the inside by being up against another piece of wood, rather than being up against the metal and the more extreme heat. I'm also paying attention to the orientation because I want the 2 pieces of wood to have mirrored grain around the guitar. So the piece at the top has to go in with the darker grain in one direction, and the piece at the bottom has to go with the darker grain in the other direction. Now we apply heat so that the piece will be nice and toasty by the time we put it in to the bender. And then we'll be applying more heat to the top through the layers of steel as we bend. Now we've got it mounted in the bender, I want to make sure it's straight. And that means I've got to check the work, not the pieces are flashing. I need to get the mould in the right position as well, and I need to make sure that the work is positioned so that there's enough length at each end. Once I'm happy with the positioning, we can just start to screw down the top waist press screw to hold it steady. We're not doing that bend yet. And we can move this piece up to the top and then start to apply heat from the top to the part that we want to bend. So I'll bend the lower bout first. And that's the easiest curve. We can do that with these spring-loaded holders. Now I can do the upper bout, and for that I can just use the secondary press screw that we will be using later for the cutaway. Now that we have the two bouts in place, we can gently apply more heat to the waist area. Now it's actually protected by the actual plunger piece of wood that we'll be using to do the bending, but it's getting a lot of heat from the underneath as well, and metal conducts heat very well also. Now, when I'm happy that that's nice and hot and that we've got steam in amongst the wood fibres rather than just hot water, then we can start cranking that press screw down. A little bit at a time. Right, with the waist press screw all the way down, I've left it sitting there with the heat lamps on for about 5 minutes. So now we switch them off and we let it cool down naturally for about 45 minutes to 1 hour. Let's see how it turned out. There we go. Now we need to let that completely dry before we take the next step. While we're doing that, we've got to do the cutaway side. We now get to the most nervous part, the cutaway. So it all is a matter of playing the heat gun over the part that is doing the bending and watching the alignment of the secondary press screw, slowly tightening it up. It is of course very satisfying to get both the press screws down all the way in without hearing an ominous crack. 5 more minutes sitting there at heat, and then another 3/4 of an hour cooling down in the mould. So let's see how the cutaway side went. Quite nice. Doing the bindings is almost the same, except you have to be a little lighter on the heat gun because there's not so much material and there's a bit of a risk of scorching the timber. Okay, let's see how these bindings turned out. They're looking pretty good, but they're a little waterlogged. So they can be set aside to dry. We're not going to need them for a little while yet. Now that the sides are dry, we're going to laminate them together. And to do that, we're going to be using these laminating molds. As you can see, I've lined the edges with masking tape because I know from experience that squeeze out is going to be a problem. One of the cardinal rules of luthiery is always to use tight bond original. This is so that a repair person can cleanly break the joint, clean it and restore it. There are some exemptions for superglue, but one should never use polyurethane. I am using polyurethane because I have found it produces the best results when laminating sides, and honestly I don't think that these sides are going to delaminate and need repair. While clamping up, it is very important to make sure that the work is aligned with the mould and the two laminations are aligned with each other. It's a bit disappointing to have to undo a whole bunch of clamps to fix that sort of thing up. So we start in the middle and then we work towards the end. Now we wait for this monster to set. We could start on the other two layers, but I don't have enough clamps.
You can never ever, you can never ever, you can never ever have too many clamps.
Now let's get these clamps off and see how it turned out. There's always a risk that the glue will stick the work to the mould. We can see that some of the polyurethane has seeped through the cheaper pine. That's not a problem. If anything, it'll make it stronger. And it's pulling away some of that tape we put on the edge. That's good, that's why we put it there. And the show face is looking pretty good. A little bit of bleed through there, it's not going to be a problem. Now let's do the cutaway side. For the cutaway side, the most important area for the alignment of the two layers is the cutaway. So we're going to be clamping those areas first, in contrast to the non-cutaway side where we clamped the waist first. As before, I put a few clamps just sideways like this to keep everything aligned while we clamp. I'm using my strongest clamps on those two cutaway areas because that's where the curvature is strongest. Quite a monster we've created here. And once again, you need to let the glue cure. Another good result. So now it will be time to trim them and to fit them into the solera. Now, first of all, with a knife, we trim away some of the more extreme bits of squeeze out so that we'll have a flat surface that we can trim the ends square. It doesn't have to be perfect, but we really do want square ends. This bit is really quite ridiculous, isn't it? Here is the Solera mould that we will use for the next part of our build. And at the join line at the neck, I've created a shim so that the width of the neck will be centered where we want it on the body. We will be clamping these two pieces together. The next part is a tricky iterative process where we make marks, cut along those lines, and then see if the piece fits inside the mould. We want it to be tight enough so that when we clamp the two halves together, everything fits snug and doesn't move. If we cut too much, it's going to be loose. That's not a problem because both of the joins are going to be covered up by something else, but it's best to get it right. Well, I didn't show all of the iterations, but we now have the sides inside the Solera mould. One of the ends is a little bit short. The others are a little bit long, which means it's quite tight. We've got some turnbuckle clamps holding it in place. And the next step is to level the top of the sides. That's the part of the sides underneath where the soundboard will be. And for that, we need this nice reference flat surface. What I'm going to do now, and you won't be able to see this, I'm going to take a pencil on one of the flat sides of the hexagon and run it around the flat surface, drawing a line on the inside of the sides. This line is going to be our reference for the top of the sides of the guitar. I neglected to mention earlier that I have checked that the sides are nice and perpendicular all around the perimeter of the guitar. Now that we have this line scribed just underneath the edge, I'll be using plane, a spoke shave and a flat sanding stick to take away the wood up to that line, leaving us with our reference edge for the top of the guitar. The spoke shave is the most effective tool for this job. However, if the grain is not perfectly aligned, there can be some tear out issues, so we must be very careful of that. Up at the edge, we may even need to use the chisel, but of course, care is the most important thing rather than speed. We're tearing this up a bit, let's try something else. Because I was having a little bit of trouble with the tail end pieces sliding against each other, I've glued a piece of scrap right in the middle. We're going to cut this out and throw it away because it's going to be where the access port is. So we'll be back once this glue is cured to shape the back. My design calls for a curved back, so to get the measurements started, I've made marks at each end as well as the 1/4, halfway and 3/4 points. And now I'm going to attempt to join them by a curving line. It gets really tricky around the cutaway, but we're going to solve that problem when we get to it. I finished roughing in the line in light pencil. The measured points are in darker pencil, and just as we did earlier, we just need to remove all of this material. But it is most important that we get a nice smooth curve, so I won't go too close to the line at this point. For some of this removal, right at the neck, we might even use
the most useful saw in the world.
Not pretty. We've got a lot of the bulk material removed, and it's now time to finesse the curves. Now, one way we do it is just by looking along the back from a very low angle and see the curves that we want to see. Now, that only works if you've seen it before, and on my website I've got images of the sort of shapes you want to see. We do the same thing here. But this is all about doing it with not so much experience. So I've got a radiused sanding block that we use to do this part, just the area around the cutaway, because that goes down, comes up a bit, then goes down a bit. It's quite tricky. And then we have a deeper radiused sanding block that we use to do this area. And by switching between the two and working on the bits that are high, that stick out and grab, we're going to get there. I have hit all of the height marks I made earlier. When I'm sanding these two radiused sanding sticks, the feeling is smooth and even, both in this direction, up here, and across here. When I turn the guitar over, we get a more or less smooth rolling motion. And when I look along from the direction of the neck join and from the direction of the tail, I see the smooth, symmetric contours I want to see. We're not going to dial it in any further at this stage. That needs to wait until we fit the inside components of the access port, the neck block, and the kerfed linings. So that'll be it for now. Join us next time. Cheers.